My talk today is about quick introduction to geospatial data. And as a data scientist at UrbanLogiq, my company working solely with government. And so government has a lot of data across like different departments, but in order to make a decision, they only have access to like one specific data that the department produce, or maybe even within a department there's a lot of data silo, and we come in and have them to have all the data in the same place. And the easiest way to show them the data is on the map. And so lots of the time I have to work with geospatial data, and I think that's a new oil. Well, you hear a lot of like data is a new oil, but with the data, I think geospatial data would be the new air, maybe, because it's like abundance. But it's a really useful and have a lot of potential. And so, okay. Okay, so for the talk today, sorry, I haven't like delete the title, but so the agenda for today is we're going through like 4 main points. First thing, I will talk about what is geospatial data. Talk about what is it, what is the popular usage and application of this data, what is it that you I'm so excited about that. And then I will talk about briefly about basic data exploration using Python, just like a few line of code, so you can see that it's a really easy to work with them. And then I will talk about some popular tools, some things that out of the box software that you can use and grab and explore geospatial data, even if you don't know any code experience, you don't have any coding experience. And last thing is that like some further exploration. So it could be like some data sources that you can, after this, you can grab in and play with it, or some map provider, so you can play with it more on like a larger scale, or like some popular algorithms that people use to work with geospatial data. Okay, so first, let's talk about what is geospatial data. Geospatial data, think of it as like numerical data. It's like a part, basically it is numeric data, right? So it has the coordinate of like latitude, longitude, and sometimes altitude. So it's like the geographic location of a physical object. So for example, think of like where is the building that you are staying, or like the street that you are walking to walk, or like a town or city that you stay in, or country like Canada, right? So the geospatial data will contain information, the geographic information of those physical objects. And so like some example of it, like for example, you think of the coordinate of an object, like latitude, longitude that I mentioned, or altitude, or like elevation. So sometimes when you see like, for example, mountain, right, in different altitude and things like that. So most of the time, geospatial data, most of the time when you work with geospatial data, it will be mainly having latitude and longitude, and less so on like altitude. Unless you need it specifically for that. Other name of the geospatial data, for example, like spatial data, or geospatial data, or GIS data, or geodata. People can refer to them for different names. And some of the source of those data is, like, for example, like coming from sensor. So anything that's sending, so normally when you think of sensor, you think of like, oh, like the sensor that they put it in like, let's think, like for example, in the crops, they put a sensor to collect information about like the crops, or like about like the range, like the water level of the rain. But actually, like in your house, there's a lot of sensors too. Like for example, if you have like smart light bulb, or like camera in front of your home, or like smart fan, right? The Dyson fan, for example. Those are all of the sensor that was sending data information into like some kind of cloud storage. And then also some other data source, like for example, infrastructure. So when the government put out like the planning for the cities, they have to have a geospatial data of all of those buildings. And those like kind of like geospatial data for infrastructure. There's another really big source of data, of geospatial data, which is coming from mobile phone. So your phone have send a lot of data to multiple vendor. So any app that you use, so I'm not talking about map, because for map you definitely have to send location, but some other map also collect your location, and they collect the location either whenever you open the app, or whenever, if you don't select to opt out, they can send your location when you close your app too. And if you say that, okay, I don't have a lot of app, and I don't even have data on my phone when I'm not at home, your location still can be sent using like phone tower, because like if you still have the phone service, it still can send your location. So that is some of the data source coming in. Okay, so look into this. It's easier to see it visually, right? So like, for example, like the building with like the height, the footprint, the zone commercial. So this is like kind of the infrastructure data that I mentioned. These are some other information that coming with the geospatial data. Or like you could think of geospatial data for like trees, like all the greenish area or park area, or like some kind of like electrical lineage in the city. Other geospatial data example. So these are two of the most popular geospatial data that selling on the market. One is called connected vehicle. So connected vehicle is that data coming from sensor inside a car. So most of the new car has a sensor in the black box, right? And then so it will send all the information about your car to the car vendor. So for example, you have a Ford or Tesla, or Tesla is definitely, or like a kind of like a car from GM, for example. It will send, for example, one of the data sources that we look at has sent the data every 3 seconds. So every 3 seconds you in the car, they will send back the location of the car, the speed, the direction, or like what is the behavior. So for example, if you do a lot of hard braking or hard acceleration, the data will be sent to the data source too. Another one is also really popular that I mentioned earlier is called location-based service, which is data coming out from phone. So depends on, so some of the big company will send their own data coming from the app, but generally each app only have a little bit of data, a little bit of the market. And so that come in the data vendor who come to a lot of apps, like for example, 400 apps or like 1,000 apps. And then they collect all the location data into one place and then mash it in and sell it to each app, to whoever want to use the data, right? So that's some of the data source. If you have any question, feel free to click on ask a question, and I can explain more about any of those. It's really interesting. It's scary at the same time, but in this war of massive surveillance, it's really hard to not leaving any digital footprint. So keep that in mind. So this is some of the application using geospatial data. So for example, in fraud and abuse, this is one of the prominent use of geospatial data from bank. So for example, if you always use your card in Canada, and then one day there's like some use of your card, for example, withdraw like $2,000 from another country, like for example, India or Australia or somewhere else, right? The bank will immediately flag it and block the transaction. That is one of the use of the geospatial data. So they can see that, okay, most of the time, the user is in here. There's no way that the user is in here. If the user doesn't report to us that they are on vacation, we will block it. So it happens sometimes. It happens all the time. So that is the fraud and abuse. In retail, for example, like if you are like a company, a retailer, and you want to find out where is the next place you want to put your shop, you want to look into the map and see where is the demographic that's gonna go to your store, and then you want to put like a store nearby those area, right? And then you also have to see, oh, where is all my competitors store located? Do I want to put a store near them, or do I want to put a store like away from them? Things like that, right? Other things like, for example, financial service, healthcare, disaster recovery, defense, intel, infrastructure, energy also use that. And so like in, for example, in because we work for government, there's like a lot of applications spending in like multiple use case, but our dominant use case that we did a lot is traffic. So for example, when the department of the transportation department look into the road and then see that, okay, this is the area where there's a lot of traffic jam. How do we see that, like, where are those people coming from? Can we build a new road to decrease the traffic jam? And then, is there any other reason leading to this traffic jam? Is it because everyone going to this road to a specific mall that maybe we can like work with like other department to put another mall, encourage people to put another mall somewhere else to decrease the traffic here, something like that, right? So it's another way of using the geospatial data. So now let's talk about a little bit about data exploration. First, let's detect some geospatial file. Whenever you see like a GeoJSON, that is like the most popular. The second most popular is shape file. So if you see that if it has a dot shape or dot shx, those kind of files also shape file. Other file could be like, for example, .csv could be a geospatial file if it has a geometry column in it, or like a lat long column in it. So like latitude, longitude. Sorry, did I speak too fast? Was I fast? Okay, that's good. And the last thing is another file format is JSON file. So those are kind of like some of the file. And then to work with it, most popular one, you can just use pandas, or you can use GeoPandas. So GeoPandas or Shapelist are two of the package that we use a lot to look into geospatial data. It may not be the best for big data, but if you just want to exploit, it's the package you go to. So for example, in here, I read in two types of geospatial data, one with .csv and one .json, right? And then you see that the .csv, I use pandas to read in, and it has the latitude and longitude column. So that is when you see that, okay, this is geospatial data. And the other one is that it has a geometry column. So it can have like multi-polygon in it, it has polygon in it, right? And then when you plot it out, it will look like this. So for example, the first one, it has longitude and latitude, and it could construct a point. So a point is like the smallest kind of geometry object. And then lots of point construct a line string. And then if it's like if it like create like if lots of point, lots of line string create like any kind of shape that you think of, it could be polygon. But if the polygon is, if you have multiple line string and multiple polygon, we have the multi-line string and multi-polygon type. So you can look into Shapely package to explore those kind of shape. But if you just only, so in here, I read in actually like the path of the storm Florence. And so if you only plot it out, you don't really see it in like what exactly where it's going and what's going on, right? You need it to be on the map. And so normally you will need to have like a base map in order to see things, especially for geospatial in geospatial data, right? So like put things in context is always like what you need. And so with the map, you can put the path of the Florence storm, and you can see where it's coming from, and then where it's going to, and the change of the speed. So next thing, talking about popular tools. So if you don't know anything about geospatial data and you still want to look at like some of the data, what can you do? So some of this tool would help you. This is like out of the box tool that can help you to work with geospatial data without having to know like much about programming, or at least working with geospatial data using Python or any kind of programming language. Or if you just want to have a quick dirty look, but sometimes you're lazy to plot, like write all of those, like plot it, you just want to see it, right? So the first one is Tableau. Tableau is a data visualization platform. I think maybe lots of you will know about that. If you know so that, just say show your hand in the chat or something. Anyway, so Tableau is great data visualization that you can put the map on, to put lots of the geospatial data to explore in it. The downside of it is that it's not a tool that specializes in geospatial data, so there's not a lot of specific tool for that. While the other three is specialized tool for geospatial data. So the second one is QGIS. So QGIS is a free and open source desktop application. So this tool is really good for geospatial data. You can do a lot of viewing, editing, analysis of geospatial data using this. The downside of it is that it's very heavy to install on your computer. So I think the newest one is about 1 to 2 gigabytes to actually download it and install. So you see this like how big it is, but it's a very well-rounded tool. It's free and it's open, and so it's really good. The third one is Kepler.gl. So this is a tool created by Uber, and this is also free and open source, but it's a website. So it means that everything, you don't have to install anything. You just go into Kepler.gl and you drop your geospatial data there and you plot it on the map. It has a lot of tools to support like viewing and analyzing geospatial data. It's really interesting. It's really good. I would have like a quick demo right after this for the Kepler.gl to see that the potential of it. And the last thing is Esri. So Esri is actually a very popular tools for GIS. So for people working specifically in geospatial data for government. And because lots of the time they don't know how to write code, they use this tool to help them mapping things and kind of like it also helps them to store the data, help them to manage all the data and linking things to each other. So this is like, but it's a paid system and it's pretty expensive. Well, it comes with a lot of things and support too. So that is some of the popular tools for you. So next thing, I'm going quickly onto a Kepler.gl demo. I just really like this. So if you type Kepler.gl, you will go into this site, right? And then when you click Get Started, you will lead into like a page where you can drop the data in here. If you don't have any data, you can click on Try Sample Data. So they have a bunch of different kind of use case that you can look into geospatial data. But let's look at California earthquake, for example. You just click on that, it will load the data and it will show you on a map. So immediately the geospatial data will show you on the map where it is, right? And down here, you see the timeline. And the fun of the timeline is that it can play. So for example, you want to see how is it over time, over year. Like for example, this one is earthquake, right? You can see how it go over year. So you see like there's more and more earthquake. And then if you show the legend, you can see the magnitude. So there's more and more earthquake with like higher magnitude too in this one, right? If you open it more, you can see like all time, or you just want to see like a small time, right? And then on the side in here, you can change color, you can adjust, you can do the filter on the data. So for example, you want to select a field to filter. For example, you just want to see all the one that with high magnitude. You can filter that. Let me show all the data all time, right? You can filter the data, you can see all of it. You can just select and see that, okay, where is the data? Like so for example, if you click in here, you can see some information and you can change it here. So this is a great demo tool if you want to like just show it quick and quick for a business team. So this is like a great thing. Like sometimes when we do some kind of visualization on our data science team, we will do like a demo or like a quick things on Kepler and show to business team. And then they will be like, oh, this is great. We want to integrate it into our platform, for example. Then we can actually work with the dev team to create the feature. But in here, it will be like a quick and dirty things. Or sometimes you got like just geospatial data. You just want to see that are they all in the place that you wanted it. Like for example, you put it in and you have all the point in land, but there's 1 or 2 point on the ocean. You know that those are like troublesome data point, right? You need to fix it. So that's Kepler, quickly a demo of the Kepler. Another things that about Kepler is that you can actually, if you want to, the thing with Kepler is that it is a website. So it's only load the amount of data that your browser can handle. So it means that it's really limited to a small size. So if you want to load it into like a big size, you will integrate it into Jupyter Notebook. And they do have a Python package to integrate with Jupyter Notebook. So you can like load in a much bigger data set and show it on your notebook. So like, for example, you just say from Kepler.gl import Kepler, and then this will show, and on the image in here will show in your notebook. And you can like, and then on that, you can perform the same kind of configuration that I just showed you earlier. Okay, so that is like some kind of popular tools that we use a lot. And then some further exploration is the data source. So if you are interested in this kind of data, where is the place that you can go and look for the data to start like playing with it, right? One of the first one I always suggest people to look at is open data. So open data is almost every government has some open data, which is data that they publicly share with the city, like with the citizen of the cities or with everyone. So everyone can look at the data. So for example, Vancouver has their own open data portal, or any like US city has the open data portal. And you can go there and search for example, crash data, for example, and see like what is the crash data change over years, something like that. And you can plot up on the map or just drop them on Kepler. The second thing that you can look into, so the other two things is location-based service and connected vehicle data. Those two data is harder to get because lots of privacy reason related to it. Imagine if you can track someone from home, it's very troublesome, right? And so because of that, the data vendor for location-based service and connected vehicle data has to be very careful on who they sell the data with and how do they accumulate the data, as well as pre-processing the data before giving it to us. So unless you have, so that leads us to like sensor data. So for example, if you have some smart device at home, you can look into whether you can access the data yourself and then play with it. So that is another source that you can look into it. Kaggle data, there's like a lot of data set on Kaggle competition that has geospatial data. So you could browse onto that to get some geospatial data, and there's good chance that there's people who also do some exploration data analysis with those geospatial data. So you can see some more exploration using geospatial data on it. The last one that you can look into is map provider. So for companies that looking into leveraging geospatial data, or like just the individual want to explore geospatial data, Mapbox or Google, Mapbox is an alternative of Google Map. So for example, Google said that if you use Google Map, you can't put anything else but Google things on it map. So that's why if you look into Kepler, they actually use Mapbox maps, because Mapbox has a less restricted requirement when people use the map. So, and so but like both of those companies, Mapbox and Google, besides providing the map layer for any kind of, if you look at, you use any application that have the map base, you can see that like those map is like have to come from one of those provider. There's a bunch of provider out there. But yeah, so like besides providing map, they also provide some a bunch of things on the API. Like for example, Google provide popular like business location API, for example, or Mapbox provide travel tab. So for example, if you select like a road at a specific time of day in the week, it can provide you like travel time. So how long does it take to go through this street? Or what is the average speed people take to go through to this road, something like that. So there's a tons of things on the API to explore. And normally they give you like a few free call. But if you're a company, you could work with them for like a much better deal to get like a bulk data dump or something like that. Okay, so last thing, some further exploration is popular algorithms. So this one, I think that it would be once you like dig deeper into geospatial data, there's a lot of algorithm that you may need to use, specifically in, like, for example, spatial querying. So for example, when you are given like of all of the point in US, and you want to find out if my point is in Illinois, for example, how you can find that? How do you find it? You have to like do compare to like what exactly you have to compare, right? So that leads to kind of some like algorithm to help with the indexing to be much faster, because so for example, like if you see in the picture in here, this is like the picture showing like archery. So archery is like one type of like spatial indexing that helps to like index it out spatial. Sorry, the way I'm explaining it may be like a bit confusing, but just think of this, right? So you have like, if you have like the T and the U, it's like the two big spatial, you start divided it into like those two big bounding box. Think of it like bounding box, and then from each of them you start like divide them into like smaller bounding box, and the way that you divide it depends on different things. Like for example, when you have ping of mobile phone for the whole US, right? You may group them by the number of ping. So you can see like, okay, so like you can have and then so you can divide it, the US into like, for example, like 50 or like 100 box, for example, and it's not depends on it's not depend on the it depends partly on geospatial and partly on ping. So it's like kind of like cluster of ping. So for example, you think of like different cluster in somewhere, and then you start section them out, and then you draw like the bounding box around it. And so that is much easier to compare like a point to like different box to be, okay, is my point is in this box? If it's not in this box, then you start like narrow down the location of the point. So for geospatial indexing, there's like a lot of algorithm that you can look into that. The most popular one is archery, and it's already implemented by several package like GeoPandas doing it, or like PyGeo. PyGeo is a much better one that you see. It's like a Python binding on top of C, and so it's just faster than Python if you need to do a lot of to handle a lot of data. K-nearest neighbors is also another kind of geospatial algorithm. And then if you look more into it, this geospatial data go really well into like graph algorithm, because like think of like graph data kind of helps to visualize like geospatial data, and then the connection between like some object could represent, like for example, like street, right? Like each intersection is a node, and the road could be like an edge, something like that. And then so it leads to like a lot of application for those graph algorithm on to geospatial data. Like for example, a shortest path. Like what is a shortest path coming from home to office based on travel time, based on distance, or maybe like based on some other things. So different street segment has a different weight, right? Or like page rank, or so page rank, I think that's one of the popular algorithm behind Google search. And so that is one of the things that also is really popular in geospatial data. And the last one is not the last one, but like one of the one I want to mention in here is random walk. Also, if you look into like graph neural network, it will be something to look into. Okay, and lastly, these are some of the resources that I want to put in here if you want to explore more into geospatial data. The first one is Introduction to Geospatial Data using GeoPandas. This is like a tutorial that I put together, and it shows you how to plotting out the path of the storm Florence in the US map, and how you can color them by speed. But you can also, with those data, you can also drop them to Kepler to see how fast it can be without having to code, producing pretty much the same visualization. I also put the website Kepler in there and the GitHub repo. So if you want to look into using it with Geospatial Notebook, there's a tutorial there. For the data policy, because you're dropping your data into the Kepler website, you would like to read onto the data policy of Kepler and related question in the issue to just to make sure that they don't store any information, or like they don't collect any information that you don't want them to collect. And lastly, that is like a post about some geospatial search algorithm that I think would be interested for everyone to read about.
I have encountered a data set that I only had X and Y to indicate the location. How can this be used to know the location?
Okay, so thank you for your question. So X and Y could use to indicate the latitude and longitude of the location. And so if you use GeoPandas, you can't see my screen anymore. But so if you use GeoPandas, it has the function called GeoPandas.point from XY. It literally a point from XY, and then you put in the first argument is the I think the first argument is X, the second argument is the column Y, and then it gives you the new column with geospatial, like with the point, geospatial point, and then you can just do that data set dot plot and we'll plot it out. So one thing that you have to be careful that I forgot to mention in here is that sometimes the coordinate may not be in the global coordinate. So if you plot it out on top of the map and it doesn't make sense, look back to see if the coordinate is called the CRS of the data set. And then if the CRS is not a global one, then you would have to convert it into global coordinate system.
I wonder if you're involved in projects related to CO2 emissions reduction or projects related with agri-food industry.
We did have some project in we want to reduce like carbon dioxide emission. So the projects not in agri-food industry, but not in agri-food industry, it's more related to car. So for example, because we work with a lot of transportation department, and so transportation department want to look into how to reduce the what is called VKT or VMT, which is vehicle kilometer travel or vehicle miles travel. So which means that, so for example, if you live in Mississauga and work in Toronto, you have to drive really far to get to work every day and back, right? So how do they decrease that? Can they either like make the public transit better, or can they bring more business to Mississauga? So people who live in Mississauga can work in Mississauga, or maybe they can make housing more affordability in Toronto, so people who work in Toronto can live in Toronto. So that is some of the projects that we work with the government to for the purpose that decrease the carbon dioxide emission through decreasing the vehicle miles travel or vehicle kilometer travel. Depends on whether like you are Canada or US government, they use different metric systems. So yeah, but it's the same idea, right? So that is kind of the projects that we work with.